Swayam Prabha. Digital India. Educated India.
So with that background in mind, let's go and try the study the first data structure, something called as the hierarchical trie. So what we are doing right now is, we understood that trie-based algorithms are software implementations. They are going to work better for the lookup operation. Can I extend the same thing for the classifier as well? Classifier also, of course, has got set up rules, and those rules are also in the prefix format. Assuming all the fields are expressed in the prefix format, we can use this kind of the trie-based algorithm. So what is the hierarchical trie? We'll try to understand with an example. So let's say I got the rule with the two fields. For the sake of simplicity, I am taking two here. R1 is having a prefix 00 star, and the second one is also 00 star, and R2 is also got another set of prefix. This is 10 star, and this is 0 star. You can simply think of this might be the source IP address, and this is the destination IP address. Assuming only these two fields, I want to do the build the classifier. So rule R3 says any prefix with 10 star, and then the D2 also will have 10 star, and R4 says this is 11 star, and then this is 11 star. Now I want to build a kind of the trie-based data structure. And the way hierarchical trie works is, you take one dimension at a time and then construct a trie, a binary trie for one dimension, and then go to the second dimension and then construct a trie for the second dimension. So as many number of the dimensions you have got, those many times you need to do this construction operation. Wherever it is applicable, you need to construct a binary trie in the hierarchical fashion. So first let's take the case of the dimension D1 and then try to build the trie. And the rule R1, first the source IP address field is actually saying 0 followed by 0. This is 0, this is 0, and this 00 star is taken care. I am going to mark this with the to indicate the this one. And the second possible prefix is 10 star for rule R2 and R3. I am going to have a node here, and then a 0. I am going to come back 1 followed by 0, and I am going to highlight this. And the third, these two are taken care now, and the third possibility is 10 star. 1 is already there, and I am going to have a node here. This will denote the 11 star. So for all possible prefix combinations of the first dimension, the job is done now. Now what I am going to do is, I am going to construct a second level trie. This kind of the trie is for the dimension D1, and I am going to do a construction for the second level. So what are the unique combinations? 00 star is in the rule R1. So when this is applicable, it is applicable when R1's the first dimension is 00 star. So that is the chain from here to here. What I am going to here is, I am going to add a link. This is a no cost link, or you can think of as a dummy link, and go to a node which is the root node for the second dimension binary trie, and construct the anytime. So this is 00 star. I am going to differentiate the first dimension, second dimension with the circular nodes for the first dimension and the rectangular nodes for the second dimension. So this says that on 0 is 00 star. So you go here and mark this as a parameter. 00 star for the first dimension, you came here, and another 00 star, you came here. This is the node which is representing the rule R1 in your classifier. So remember, this doesn't cost you anything. You are not reading anything from the header. So rule R1 is done now, and rule R2 is take what it is saying 1 0 star. So this is the node which is representing 1 0 star, and there are two combinations. R2 says as usual I am going to have a dummy link or the no cost link from this node to the next level root node, and then on 0 it is else. This is the rule node which is denoting or representing R2. This case is now taken care, and to go to rule R3 and for the same prefix 1 0 star, this can be 1 0 star. So on 1 you come here, and then in the 0 you go to the left. This is the node which is representing the rule number R3. So 1 0 star followed by 1 0 star is the rule number R3 that is supposed to match. As usual, I add a no cost link to the from this node to node, and then have two nodes, one on the right and second one on the right. This is the one. So this is the rule which is representing rule number R3. So this from here to here, whatever you have, this is the dimension D2. This is the set of nodes inside your trie, which is corresponding to the dimension D2. So like this, I can go to any number. If I have a third dimension, all that I need to do is again, so let's say I have dimension D3, and then the combination is something like this. Maybe the dimension D3, if it is a prefix format, let's say this is 0 star, and what I need to do, go to R1. So this is 0 0 star is taken care, another 0 0 star is taken care, and now add a no cost link to the third level. This one maybe I'll add oval shape to this one, and then 0 star go here, and this is will become your node rule number R1. So I need to highlight this. So like this, any number of the fields that you got inside your rules, those many times or those many, that is the hierarchy in the order, first from the R1 to D1 to D2 to D3. That's how I keep on proceeding. So this kind of structure is called as the hierarchical trie. So now it is easy to note that if the fields are some W bit width, so in the first level you might have W pointer references, and if the second dimension is also W field, then you will have again W number of the pointer references to do, and so forth. So if W is the highest width, when I say width, this is the width 0 0 0 1 0 star. So what is the width of this? This in this case is the 5 bit. 5 W is the width and D is the dimension. In the worst case, what is the lookup time this data structure is going to take? W times the D. So every dimension I am going to make W references. Then in all overall, to figure it out, what is the reference is going to take, one rule evaluation is going to take W cross T. And it is possible that whatever rule you are going to evaluate may not work out. You need to backtrack. Again, remember, one rule, one track evaluation. If I want to evaluate one rule, then that will take W cross D amount of the number of the pointer references. When it fails, then we'll come back to that in a minute when we discuss the performance of this algorithm at the end of or after taking a couple of more examples. So this is how you construct the binary trie, hierarchical trie, a binary trie for every dimension attached appropriately inside this structure. So let's take a second example. Here is a classifier with 7 rules, and there are only 2 dimensions just for the sake of simplicity. R1 is 0 0 star and then 1 1 0 star. And let's try to construct the hierarchical trie for this classifier. So as usual, I take one dimension and then build a binary trie, and 0 0 star is the one that I want build. So this is a 0, this is a 0, and this 0 0 star is now taken care. And similarly, another possible is You can have 0 star as this one. That's why I have highlighted this node also with the red color, and 0 star is indicated by this color. And what is the other combination I got? The other combination is 1 0 star, that is in the rule number R3. This is 1, this is a 0, and this node is highlighted. And similarly, okay, is that the only thing that you got? Okay, and star is that 0 star is, these two are taken care, 1 0 star is taken care, 0 star is taken care, and star is taken care, because this is the node which is indicating the star, the root node itself. So now let's go to the second level. When rule R1 says, when the prefix in the dimension D1 is 0 star, we came here, and 1 0 star is the what you need to look for, or 1 star. This is the rule R2, 1 and 1. This is the node which is indicating rule number R2, and 1 0 star is the one which is indicating the rule number R1. This is the node which is actually getting the rule number R1. So R1, R2 story is done now. And now, so with the 0 star prefix, 0 star, I came here to this node. I add a pointer to the level, and what are the possible combinations? One says the 0 1 star. This is a 0 and this is a 1. And this is the node which is actually corresponding to rule number R4. And then 1 0 star is also another combination. This is a 1, this is a 0, and this is a node which is actually indicating the rule number R5. And rule number R6 says 0 star followed by 1 star. This is the node which is actually indicating the rule number R6. And I continue doing this. 1 0 star at the first level, R3 case is left, and then in 1 star. So this is the node which is actually indicating rule number R3, and I continue doing this. So there is rule number R7 which is actually star. Star is this node. I took a no cost link to this particular root of the node, and then this says 0 star, a 1 you came here. This is the node which is actually indicating rule number R7. So R1, R2, R3, R1, R2, R3, R4, R5, R6, R7. All the 7 rules are taken care. That's the end of it. This is how you construct the hierarchical trie for any given classifier or the set of rules. Now let's try to evaluate. So let's say my input IP address or the one is let's say 0 for the dimension D1, and then for the dimension G2 it is 1 0. Then for these two zeros I take this path. For this 1 0 I take this path, and I see that my correct standing is at this particular node. The rule R1 has matched. So let's take the second case. If let's say the dimension D1 is still 0 and the second case dimension D2 is also 0. Now how does the rule evaluation starts? I read the first 0 and as usual I take this path, come to this particular node, and then next 0 I read, and but I don't have for the second level. I came here with the no cost link. Once I come here, I come to this particular node, and then there is no rule actually node which is actually connected to this particular node with the possible input of 0. Then what do I do? So in order to do that, what you need to do is you need to go back to this particular node or at one level to this particular node, and then try other combinations. So there is a combination. If 0 star is not the thing, then might be 0 star might work, because there are some rules which is in the first dimension which are having the 0 starting with 0 star. 0 star is a subset of 0 star. I go to the one level, high level, and then try to evaluate. So if I come to this node, then again I take the no cost link to this particular node and try 0 star in the second dimension. Again there is no link. I come here and then take this, I come here, and then there is no link or the node connected to this particular node which is having another possible input of 0. So that fails. Again I am going to backtrack all the way to this node, and again you go back to the root node, and then what is the next possible thing that I can do? 0 0 star, is it a subset of any other rule other than 0 star? It happens that star is actually a superset of 0 0 star, or in other words 0 0 star is the subset of 0 star. I try a combination with the star. Maybe I take this path and come to this node, and then I try 0 0 star. So in this case, did I write? Oh, I wrote wrongly. I think this is supposed to be 0, this is supposed to be 0. Just make a note of that. There is a typo. I put the nodes correctly but wrote 1 in the label. That's supposed to be 0. So 0 0 in this dimension I try to match, and I find a match, and I see that R7 is the best match. So remember again, if your input is 0 0 star for the first dimension and 0 0 star for the second dimension, then you first attempt R1, it fails. Second time you attempt R2, it fails. Third time you try with R4, and that fails. With R5 it fails, with R6 it fails, and finally we need to backtrack to the root node. When the R7 is star, that time second time 0 0 star is in the second dimension, will come to the rule R7. So 0 0 star and again 0 0 star for the D1 and D2 will take you to applicable rule is R7. That's how you find out what is the applicable rule for a given set of the rules and the input, or a given classifier and the input packet. Let's take another example and try to construct the same hierarchical trie. Here is the second example. So the rule R1 says 0 0 star. So 0 0 star, you come here, and second this is taken care, and for these two I am going to add 1 followed by 0. They are taken care, and the third one is 1 1 star, and this is the node that created. So this is taken care, and star is anyway taken care by making the root node itself or highlighting the root node. So one dimension is complete, and second dimension, take the first rule. This is 0 0 star, this is the rule R1. So this is 0, this is 0, and 1 for 1 0 combination. So this is the 0 star is 1, this is the rule R2, and second is 1 0 star, this is the rule R3, and the 1 1 star in the first dimension followed by 1 1 star. So this is the rule R4, and finally for a star a 0 0 star. So this is the rule for the R5. So this is how you construct the hierarchical trie, one dimension at a time. So with that background, let's try to understand the performance of this kind of the fire hierarchical trie. In terms of the storage, it requires D cross W, meaning bring in D cross W. W is the width, D is the dimension. So in every dimension, W bits number of the nodes are actually, or the combinations are actually created. So when I say D cross W, W means that for all possible combinations of the W, meaning if W is 2 bits, you need to take care of these many combinations, 4. So my tree would look like this one, 0 1 and 0 1 0 1. So this is the W bit trie, that much storage is required. This I need to replicate D number of the times, dimension 1 this one, and for every node here there is another W bit trie that is possible, that is full tree is possible. So W bit trie complete binary tree for one dimension, another W bit to complete binary tree for the second dimension. Totally how many number of the times you need to do this? D times, as many number of the dimensions. That is the storage amount of the storage that this structure will take. And the searching time in the worst case, one branch searching from the root node to one of the branch searching would take D cross W. This is the one D1 and this is my D2, and width here is W1 is 2 and W2 is also 2, and you require 4 number of the D cross W number of the pointer references for one thread. And if the prefix match fails for this case, one rule, you need to backtrack and then explore the other possibilities. So in that case, what is the worst case number or possibilities of the backtracking that I can do? And in all total, how many number of the references or backtracking I need to try is W number of the back references, one dimension I go and then I try the alternatives. So W power to the power of D. So W is the one dimension tracking, and how many times I need to do D number of the times. So I need to, in the worst case, I need to explore all possible complete binary trees in every dimension. That turns out to be W into W into W, how many times? D times. So those many times if I explore all will combination, then you will get so that is the worst case possibility. That's why the search time for this the classifier is W to the power of D. So now is it the best I can do? What is that alternative thing that I can do? W to the power of T is D is actually quite complex. Many number of the backtrackings you may need to do in the worst case. Can I minimize the number of the backtracking? And then if I want to minimize the backtracking, what is the alternate modification that I need to do inside my hierarchical tree or this data structure, or how do I actually do that? The answer turns out to be a modification to the basic hierarchical tree. This is called as the set pruning tree. What it done here is, for any combination of the rule set, if evaluation of one rule fails, and if I instead of doing the backtracking, I will explore what are the other possible applicable rules for this currently where I stand, and then attach those combinations of nodes as a subset to but let's take an example and then try to understand what I am trying to say. Let's say rule R1, we have got two dimensions D1 and D2. Rule R1 says the first dimension is 0 0 star and the second dimension is 1 1 star, and rule R2 says this is a star and then this is 1 0 star. Now construction of the tree as usual start with the one dimension at a time. Now let me construct the hierarchical tree for this one and then try to do the modification. So 0 0 star will take me here, and then I will highlight this, and the second is star itself, and I will make this node as the this is the first dimension D2, all combinations are taken care. And now I go to the second level and then try to build the so I here add a no cost link to the second, and then I take 1 1 star is a combination. So I add a node here, this is on 1, this is on the 1, and I let this is the rule number R1. The second one says when the D1's prefix is star, that time on a 1 0 combination I am going to match the rule R2. So I will add a no cost link to this one, and then 1 on the right hand side and 0 on the left hand side, and this is the node which is actually denoting rule number R2. Now let's say the input, the packet has got this combination, D1 has got 0 0 star, it might be more than 2 bits, that's okay, and D2's fields are starting with 1 0 star. Now I take these 2 bits and I traverse this link, and then I with no cost link I come to this node and then try to read 1 0 star. So 1 is there, I come to this node and then try to read 0, and it is not possible because there is no left child to this particular node right now. So that is not possible, and I need to backtrack. Backtrack where? So what is the other possibilities? What is the node? If D00 star is not applicable, what is the other rule that is applicable? Here in this case of the star, from here all the way to this start node, I am going to backtrack. So then I will try to explore, because 00 star is a subset of star. This rule R2's case is valid. Now I try to read 10 star. So I come to this node, 1 I come here on the dimension D to this one, and then on the 0 I come to this node. Okay, that is matched. Now I say that for 00 star, 10 star, rule R2 is the one which is actually applicable. This is the best match that I can find. Now this requires backtracking all the way from this node to the root node I went, and then if let's say I don't want to do the backtracking is the one which is actually adding complexity to my hierarchical tree. That's why this runtime, the lookup operation is becoming expensive. What I want to do is I take these rule sets, and then 10 star is another possibility that is applicable when 00 star is also a prefix. So I take that combination and then add that rule, the corresponding nodes to this in itself. So let me highlight that with a different color, maybe with the color. This is the 0. When your input is 00 star, as is the case in this one, and 1 followed by 0 is valid, but it is valid, it is taking me to say that this is the rule number R2. By replicating when the input is, let's say, possibility, if packet, let's P1 and P2 has got 1 star and then 10 star. So in that case, evaluation of this one anyway, if I don't have any child with the value with a value 1, so only possibility is to treat this as a star and then go to this node and then do the elevation. 10 star is matching. But even when the 00 star is there, that time also can, because of the second dimension evaluation fails, I need to evaluate or explore the rule number R2. Rule number R2 is applicable when the dimension D1's first rule 00 star is also a possibility. That's why I replicated here. So this avoids by taking such applicable rules when one is the one rule prefix is subset of the other one, such overlap is possible. I am going to do the node replication and then appropriate branches to the existing structure, and then try to avoid the backtracking. Thereby I bring the efficiency, or the number of the pointer lookups are actually minimized. But this comes, it is obvious to note that, comes at the expense of the node replication. Node replication implies that you require more storage to store your classifier to keep it in the router. The memory, overall memory size requirement is going to increase. So this kind of the structure which comes at the cost of the or the expense of the storage space, but avoids the backtracking, is called as the set pruning tree. Let's take a couple of more examples. So here is a classifier, and it says that you construct the set pruning tree. So let's again do one dimension at a time. As usual, let's first construct the hierarchical tree. 00 star, this K combination, I have got 00 star. And then a star is also possible, that is also the root node is highlighted. These two prefixes are now taken care. 10 star is another possibility. This is the one, this is a 0, this is the node which is corresponding to 10 star in the dimension D1, and 1 star is the another possibility. Is done. Now let's go to the all combinations in the first dimension are taken care. Now as usual, let's go here. So 00 star is the another possibility, 10 and 0, and this is the node which is corresponding to the rule number R1, and with that R1 again I continued this. 10 star is there, I came here, and then with the 0, this is the rule number R2, and then this is taken care. This is 10 star is 1 followed by 0, this is the node corresponding to rule number R3, and again 1 1 star, and then this is the one, this is a 1, and then this is the node which is corresponding to rule number R4, and finally now at this stage we have constructed for all the combinations. So, okay, one more is left out. This is this combination. This is the node which is corresponding to rule number R5, star and then a 0 and a 0. There is a little as in the order in which they are appearing. Now you need to replicate the rules. The nodes which are actually highlighted in the green color are the nodes which are replicated. So what are the rules that are replicated? So when the input is in the first dimension is 1 0 star, you came here, and then if your subsequent input is 0, you came here R2, and if that fails, if let's say the input is this one, 1 0 in the dimension 0, and D2 is 0 0 star. So 1 0 star I came here, and then reading the first bit of the dimension D2 I came here. I am trying to explore whether 1 0 star and to this rule number R2 is applicable, and I read the second 0, then I have 0 0 star. 0 star is actually a subset of the 0 0 star. But in that case, instead of saying that this is the rule number R5 is more specific than the R2, and what I am going to do is I say that instead of doing the backtracking, I am going to say that rule R5 is applicable here. That's why I replicated this rule at this point of time. Similarly, if the input is 1 1 in the star in the first dimension, and then a 0 0 star in the second dimension, so 1 1 0 star I came to this node, and then on a 0 and a 0 I came to node. So if 1 1 star, I am looking for when I am reading the 1 1 star of the first dimension, I am trying to evaluate the possibility of the applicable rule R5. If that fails, then second time I am supposed to get a 1 1 star, but that is not happening. So if that is not the case, I am going to try another rule which is the possibility of R5. So which is 0 0 star. So this is going to be R5. Even if the prefix in the first dimension is 1 1 star. So 1 1 star is a subset of the star, and in the second dimension I didn't get 1 1 star, but then I need to backtrack, and then instead of doing that I also say that 0 0 star is applicable right here. So by doing the right replication I am here. So that's how I construct whatever is the applicable rule for that combination. I am going to add the replicate the rules and then construct the set point try.